Hi students, today we are going to see a quick recap of structures of IIR filter. So structures of IIR filter, filters are designed by considering infinite number of samples of an impulse response is called as IIR filter. So this filter is called as a recursive as the output depends upon the previous output or past output. So your IIR filter is called as a recursive. So here your y of n can be written as minus summation k equal to 1 to n, a suffix k, y of n minus k plus summation k equal to 0 to m, b suffix k, x of k n minus k. So since your output depends upon the previous output, we are saying it is a recursive. So your transfer function is given by output divided by input. So you can write in terms of your coefficients as b0 plus b1 z inverse. It goes on till your p suffix m z power minus m, and in the denominator it is 1 plus a1 z power minus 1. It goes on an z power minus n, where m is a number of zeros and n is going to be a number of poles. So here in IIR filter, both poles and zeros are there in the transfer function. So here normally your IIR filters are computationally more efficient than FIR filter because it needs only fewer coefficients because of the feedback. So they have the feedback, so only few coefficients are sufficient. So it is computationally more efficient comparing with the FIR filter. So here the structures of IIR, types of IIR structures, we are going to consider only four different structure here: direct form 1, direct form 2, parallel and cascade. So first we can go for the direct form 1. So in direct form 1, this is the basic structures of direct form 1. So here in direct form 1, they have separate delays here, right? So input and output is going to have the separate delays. Then it has m plus n plus 1 multipliers, right? So here this b1 to bm, m, and a1 to an, n. So m plus n plus this b naught as 1. So m plus n plus 1 multipliers, then m plus n adders, and m plus n plus 1 memory locations. So while attending MCQ types of questions, these points to be kept in your mind. So it requires m plus n plus 1 multipliers, m plus n adders, and m plus 1 plus n memory locations. So the equations can be written in terms of the general functions here. So numerator always this numerator or the multipliers in feed forward. So it's b0, b1, bm. So it is in feed forward, and this a1, a2, the denominator will be feedback path. So in your direct form 1, the numerator will be the feed forward and denominator will be the feedback. So now we can see, suppose in your MCQs, if you are going to give a structure, how to get the equations without performing the procedures we can see. So directly by seeing the structures itself, we'll be able to write the equations here, right? So we'll see how to write. So write the difference equation of the given structure. So this is a direct form 1 as it has separate delays. Your input and output is have separate delays here. So by seeing this structure, how can we write this equation now? So this output y of n is equal to, so this side will belongs to the output coefficient and this side belongs to the input coefficients in direct form 1. So you have to keep it in mind. So without doing any sign changes, you are going to write it as such, right? So y of n is equal to minus 0.1 y of n minus 1 plus 0.2 y of n minus 2 plus 3 into x of n plus 3.6 into x of n minus 1 plus 0.6 x of 1 minus 2. So this is first delay, this is second delay. So while writing this one, it's n minus 1. While writing this one, it's an n minus 2. So we'll be getting the equation. So sometimes the output is equal to the equation. Sometimes if they have output one side and input another side, you can write it out. So just bring the outputs to on its one side and input as an another side. So this is how we can write your equations by seeing the structures directly in direct form 1. So next is types of IIR filters. We are going to see the direct form 2. So in this direct form 2, this is the basic structures of direct form 2, general structure. So here in direct form 2, it has a common delays for both input and output. So here it requires, as earlier, m plus n plus 1 multiplier. So b1 to bm, so a1 to an. So m plus n plus 1 multipliers, m plus 1, m adders here, but the memory location will be the maximum of m or n. Which one is the maximum? That will be the memory locations here, since it is going to have the common. So number of maximum memory locations will be of maximum of m or n. So it is, since it minimizes the number of delay elements, it is also called as canonic. So why direct form 2 is also called as canonic means, so as the number of delay elements has been minimized, so we can call it as a canonic. And it involves the realization of transfer function into two parts. First, the product of transfer function y of z divided by x of z will be of a product of two transfer function, as we'll be introducing the temporary function w of z. So y of z divided by w of z into w of z divided by x of z. So now we can see how to write the equations directly by seeing the structures in direct form too. So write the difference equation of the given structure. So this is your direct form too, as the delays that you have, it has common delays here. Right. So here in direct form too, have to keep it in mind. This side belongs to x and this side belongs to y. So this is quite opposite to the direct form one. So in direct form one, this side has output, this side is input as such, right? So this side will be belongs to output, this side will belongs to input. But in direct form two, it is opposite here, reverse of your direct form one. So your y of n will be equal to minus zero point 0.1 y of n minus 1. This side will be your output. So minus zero point 0.1 y of n minus 1 plus zero point 0.2 y of n minus 2. This is 3 into x of n plus 3 into x of n minus 1 plus zero point 0.6 into x of n minus 2. So this is how we'll be writing your equations directly. So remember, in direct form 2, this side belongs to your input and this side belongs to your output. So that is a reverse. Okay. Next types of structures, we are going to see cascade form. So cascade form, this is the direct structure. So we'll be breaking the transfer function into small chunks of first order function, and then we'll be placing next to it, right? So this is your cascade form. So normally will be the in cascade form, everything will be expressed in terms of your product of the transfer function of first order. And the advantage of using this cascade form is it has same number of poles and zeros. So since we are going to break it as a first order, so the poles and zeros is going to have the same number, and we'll be considering it as an individual components. And so as I said earlier, the transfer function will be broken into the product of transfer function and factors in the denominator and the numerator, the polynomials. So normally the polynomials will be of first order. Maximum it should be of first order. If it is not able to factorize, then we'll go for the second order polynomials. Now we'll see how to write the difference equation uh, for the cascade structure. So in direct form 1 and direct form 2, we wrote the difference equation directly. But here in the cascade form, we have to write the transfer function first, and from the transfer function, we have to take our difference equation. So this is it's a cascade form. Here we have two units here. So normally this is going to be the transfer function. We are going to take the transfer function of this first one and second one. So here how to take the transfer function. This side belongs to numerator and this side belongs to denominator. In transfer function, while writing the denominator, you have the sign change. So this thing you have to keep it in mind. So this will be the numerator, right? So this, how can I write it as 6 plus 1 into z inverse. So numerator will be 6 plus 1 into z inverse. Denominator will be always the first term will be 1. So this is 0.5. So minus 0.5 z inverse. And if you take this one, numerator, this side belongs to numerator. So 1 plus 1 into z inverse. Denominator, first one will be always 1. Since it is plus 0.25, it's minus 0.25 z inverse. So after getting this h of z, You just multiply the numerator and denominator. So you'll get this. And your h of z is nothing but y of z divided by x of z. So you just cross multiply it and take the inverse, you'll get it. So you just cross multiply this. So y of z into this term and x of z into this term. So if you cross multiply, then take the inverse z transform. So y of z will becomes y of n minus 0.75 z inverse becomes 0.75 y of n minus 1. Z inverse becomes y of n minus 1 since it is multiplied by y. And this is 0.125 z power minus 2 y of z. So y of z into z inverse z power minus 2 will be y of n minus 2. And similarly, x of n plus x of z inverse into x of z is nothing but x of n minus 1. Z power minus 2 into x of z becomes x n minus x of n minus 2. So I'll take y of n is equal to something. So what happens is minus zero point 0.5, this plus becomes plus zero point 0.5 y of n minus 1 and minus 0.125 y of n minus 2, 6x of n plus 7x of n minus 1 plus x of n minus 2. So for cascade and parallel, have to write your h of z, and then from your h of z, cross multiply your y of z and x of z and take inverse z transform. You'll get your equations here. So next types of IIR filter is parallel form. So this parallel form here also the entire h of z transfer function will be broken into small pieces of first order or second order polynomials, and then it will be placed one behind the other. It's a parallel form. Right? So it will be of sum of the first order on second order sections here. So here this parallel form of realization is done in high speed filtering applications. Um, so partial fraction expansion of the transfer function in lead z inverse leads to the parallel form of your direct form one. So if you're going to use your z, then what happens? It will lead to the direct form two. So both can be done. So direct form one and direct form, mostly direct form two will be preferred. And now we can see how to get the difference equation here by seeing the structure uh, for the parallel form. So this is called as a parallel form. So this is going to be the constant. This is your h1 of z and this is your h2 of z, which is placed one behind the other in a parallel fashion here. Right? So how to write the transfer function for this one? So your cascade is product, parallel is sum. So sum is 8 plus this transfer function plus this transfer function. So 8 plus numerator is 48. Here you don't have anything. So only 48 plus 1 minus 0.5 z inverse, because negative should be, your value should be reversed. And here it is minus 50 divided by 1 minus 0.25 z inverse. Now take the LCM, and then you just cross multiply with your y of z by z of y of z and x of z, and take the inverse z transform, will get the equations. Thank you guys for your time.